Slope. Slope is one of the most fundamental ideas of algebra, and slope is the amount y increases if x increases by 1. So in this example, you see that we've created this table. Every time that x goes up by 1, so this is plus 1, plus 1, plus 1, then what's happening to y is we're adding 2. So the idea that we're adding 2 every time that x increases by 1 makes our slope 2. For some reason, we use m to represent slope. You can also see this on the graph, where every time we go right 1, we are going up 2. And here, you will also see the slope as part of the equation. Typically, it's the coefficient of x when it's written in this form. So that's the idea of slope, represented in 3 different ways. In this problem, well, we're going down 3 every time we go up 1. So we're going down 3 and right 1. That's a slope of negative 3. Here our slope is negative 3. You should see how it matches between the 3 representations. And it's consistent. In a line, the slope is the same throughout the entire line. So we're going down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. Some people will write this as down 3 and right 1 as a fraction, but typically it will be simplified to the integer, if possible. Here, we are increasing by 3 here as we increase this by 4. So between 1 and 5, we're adding 4. Between 0 and 3, we're adding 3. But the definition of slope is how much y increases when x increases by 1. So it looks like it's somewhere between 1 and 2 is how far up it's going between here and there. So what we can do is, because the slope is consistent throughout, we can say that we're splitting this entire space of 4 and 3 into 3 equal triangles. So when you're splitting something evenly, that's division. So 4 divided by 3 is our slope. Here you see 4 divided by 3 gives us the slope, and you also see a slope of 4/3. So there are a number of different ways to find slope. If you're given a graph, you'll do rise over run, making sure that you use the correct sign, positive or negative. So positive slopes and negative slopes. From 2 points, we have a formula that it's the amount y changes whenever x changes by 1. So if you want to divide the amount y changes by the amount x changes, that'll tell you how much y changes when x changes by 1. This triangle is pronounced change in. It's the Greek letter delta, capital delta, which means change. So you'll see that later in other classes as well. One way to calculate the change in y is to take 2 y coordinates and subtract them, and take the matching x coordinates and subtract them. Or you could say that it's rise over run. From a table, we pick 2 points and plug them in here. So what you saw here, we could do 5 minus 1 over 3 minus 0. That matches up with, here's x2, y2, x1, y1, and that matches up with what I wrote out here, giving us 4 over 3, which was the slope. From an equation, you solve for y, so get y by itself, and if you get, say, 5x minus 8, you'll read off that the slope is 5, the coefficient of x, once it's solved for y. Please note that you can't just say that the slope is 2 here. That's not the slope. You have to get y by itself first. And from a story, what does a slope literally mean? Well, it's how much y is changing each time x increases by 1. So determine what information they're giving you. If they're giving you 2 points, you can use those as inputs to this formula. If they tell you, it's possible to tell you that, oh, this is the rate that things are happening at. I'm making $10 an hour. $10 an hour is a slope if you're talking about how much money changes in each hour. If y is money and x is hours, then there's a good chance that $10 per hour is a slope. Mr. Slopey, if you're graphing, it's good to know what direction the different slopes mean. This is a way to remember that positive slopes are up and to the right because you're going up every time you go right one. Negative slopes are down and to the right, because you're going down every time you go right one. If you don't increase or decrease as you go to the right, then you have a zero slope. And here, what happens is that how much is y changing when you go 1 to the right? Well, there is no y coordinate here. There is no y coordinate to define. You can't talk about the slope when you go right 1 from here. So we call this undefined. Undefined lines are vertical. Or undefined slopes are vertical lines and look like x equals. And horizontal lines are have a zero slope, and they look like y equals. So our slope formula, y2 minus y1 over x2 minus x1 equals change in y over change in x is rise over run. You only need to know 2 of these at a time, but it's important that you know all of them eventually because each of them have their own uses. The delta means change in. X1 and y1 and x2, y2 are 2 different points. So the 1 and 2 are just to represent that this is 1 point, this is a second point. That's all. This is very important formula. We will use it many times. Find the slope between the following points. Well, let's label them. X1, y1, and x2, y2. Now, we say that the formula was y2 minus y1 over x2 minus x1. So, y2 was 4, y1 was 7, x2 was negative 5, x1 was 1. So negative 3 over negative 6 equals 1/2. Find the slope between these points. The x-intercept is a 0, and the y-intercept is 0, b. So we'll go y2 minus y1 over x2 minus x1. B minus 0 is b, 0 minus a is negative a, so negative b over a. Find the slope between these points. So negative b minus negative b over negative a minus a. Negative b minus negative b is 0, because we're adding, these are opposites, over negative 2a, which is 0. So this would be a horizontal line. Here, the slope is 3n minus negative n over m minus m equals 4n over 0, which is undefined. You can't divide by 0, so this must be a vertical line. And here the slope is 2d minus b, remember y2 minus y1 over x2 minus x1. So this is not able to be simplified, so that's our answer. Can't simplify that further. That's how you calculate slope.